Hello, everyone, and welcome to today's webinar, Inside Indeni for Checkpoint Maestro. My name is Alexa, and I will be handling today's webinar logistics. Your speaker today is Shai Naveh, who is the Research and Development Group Manager at Indeni. Prior to working at Indeni, Shai worked in research and development for Checkpoint Software Technologies for over 9 years. While at Checkpoint, he was a developer for the VSX product, a team leader for clustering and chassis, as well as a group manager in charge of the chassis solution series, 64,000, 61,000, 44,000, 41,000. Shai is highly experienced in working with enterprise customers with on-premise solutions and leads research and development for Indeni today. Now, without further ado, I'd like to turn it over to our speaker. Shai, the floor is yours.
Thank you, Alexa. Hello, everybody. So today in our webinar, we will discuss, this is the agenda, discuss checkpoint cluster solutions evolution. And then we will discuss a bit about the Maestro key concepts and the way Indeni supports Maestro in brief. And then we show a short live demo of the different functionalities we have with the Indeni solution, and then a short Q&A session. So generally speaking, there are three major phases for the cluster solution evolution for Checkpoint. So Checkpoint was founded in 1993, and then it was originally a single gateway solution. Then later on, somewhere toward later in the 90s, the Cluster Excel solution was introduced. And the major variations or usage in field is mainly HA or VSLS for VS6, which introduced gradually. And along the years, there were many others sub-cluster solutions like VRP and load sharing, but these are less common deployments, but they were still existing. And then Cluster Excel was the main solution for almost 20 years. Yeah, and even today, it's widely adopted. And then in 2012, the 61K platform was introduced. Later on along the years, until 2018, there was an additional 44K, 64K, and 41K. And last year, in the beginning of 2019, Maestro was introduced. So this is like a high level of in terms of timeline. Now, if you try to dive into 1 second, I'll try to use a pointer. Now, let's do a bit of a deep dive into the different solutions, the attributes, and later on there will be one of the slides will do a comparison between different solutions to see how it was really evolved and what are the optimization and improvement along the years. So now we're talking about Cluster Excel. So in terms of hardware, so Checkpoint support along the years the majority of the appliances. When I say appliance, I mean that these are the devices, the inspecting devices that the Checkpoint sells as under their brand. And there are many other open servers that was already also supported. Scale out, so it's up to 8 members. When I say scale up, I mean inside the box in terms of more CPU, more hardware resources. When I say scale out, I mean the amount of the general throughput of the whole system by adding more and more devices. So it's supported up to 8 members. The most common are 2 and 3 members in a deployment. Sometimes I was seeing 4, but it officially supported up to 8. Obviously, this is a limited redundancy and limited performance due to the nowadays this is a low figure of computing nodes when we're talking about 2020. Configuration per member. So imagine that you have like 4 members and everything you need to configure through a form UI for even simple stuff like SNMP or NTP or time zone, whatever. The members are not syncing. and you need to do the same operation over each member, and each member has its own IP. Same things go for the UI and for the CLI. Policy installation, also from Smart Dashboard, it's per member, although you can do it like in multiple checkboxes, but it's per member. Upgrade, HF, any maintenance work per member. And cabling, so many cables from the interface ports and for the power supplies, which is another thing of another layer of complexity in terms of the hardware handling. IP allocation, so there is a VIP, the virtual IP, and there are an additional IP per member. A lot of IPs to maintain in different applications, Excel sheets, whatever. And we're talking about VSLA and VS6, many VSs. It becomes very hard to track what's going on there. And not to speak of for the users who have many VS6 deployments, it's very hard. Member addition is not straightforward, as with it's not straightforward. You need to add the device to your deployment. You need to add the cabling. You need to add the cabling to the switches or the routers, and also the sync cable. You need to make sure that you have the same code manually, and then install policy after everything is all the configuration and connection table or all state tables are synchronized. Need to do quite a few checks manually and validate that the member is ready for actual handling traffic. So this is also for the cluster Excel. Traffic processing. So in HA, again, I'm not speaking about the load sharing solution because it was not widely adopted and it has quite a few limitations in terms of functionality and generally speaking. So I'm talking about the common solutions, which is HA and VSLS. So HA is very simple, but some users who like to have HA, I'm not talking about two members. In two members, it's trivial that HA will be one member is active, the other one is standby. But when we have four members, so a user has actually have insane amount of members in redundancy, because one is active, but three are actually doing nothing, waiting for the due date for them to actually start processing traffic in case there is a failure or something similar. So this is for HA. For VSLS, it's similar but different, because in the VSLS, if you have multiple members, so actually each one of them can handle traffic. So we can have multiple members handling traffic concurrently. But in the this is in the point of view of the VS6 setup. In the point of view of the virtual system, it's actually also HA, because one member handles traffic and the other one are standby. So this sums up briefly the cluster Excel characteristics. When we are going to the chassis solution, so the hardware is not it's a designated hardware, unlike the cluster Excel, which has all the variety of checkpoint appliances and open servers. So there are a limited amount of network cards, the SSMs and the SGMs, which are the processing cards, and there are actually only 3 were released along the years. And the chassis is also another box. So everything is like, this is a special device with insane performance capabilities, but the hardware is a significant limitation. Scale out, so you can have up to 12 members in a chassis. Along the years, was support for 2 chassis, so we can have 12 and 12. So you have significant inter-chassis redundancy, meaning if the whole chassis goes down, you have another chassis. Usually, not usually, sometimes it was in the same data center. Both chassis were just very close in terms of proximity. In other cases, the chassis can be located in different data centers. So we have inter-chassis redundancy. Performance. So it's dramatically increased because we have up to 12 members, and all of them are processing traffic. We'll get it in a bit, but still it's bounded. It's bounded by the box itself. With the biggest one have up to 12. The smaller ones have up to 5, the 44K. So this is an improvement in comparison to the cluster Excel, but still it's a linear growth and not more than that. Configuration. This is an improvement from cluster Excel. Configuration is per VS. So even if you have 12 members or 24 members, you do a configuration once. For each virtual system, you do a policy installation once. This is a dramatic improvement. Upgrade HF installation, you do once per chassis. So it's gradually, like you do it chassis by chassis. So we have redundancy for the setup, but you don't do it like on each of member, which will take you like 24 operations, which is a pretty high level of maintenance work. It can take days, I guess. About cabling. So cabling is much more simplified. You have multiple power supply cables for the multiple power cables, depending on the amount of power supplies you have in your box. It's expandable. And about the network card, so it doesn't matter how many SGMs you have in a box. The amount of Ethernet interfaces which are connected to the networking cards on the chassis are fixed with relation to the amount of SGM. So if you configure another port, an additional VLANs, so it will be on the same port and not per member. Imagine that you have 12 SGMs in the chassis comparing to 12 cluster Excel members, potentially. So this is much easier. IP allocation, very, very easy, the simplest that it can be, similar to a single gateway. In a single gateway, you don't have a VIP because it's not a cluster. And in the point of view of the management, the chassis is even not a cluster. It's a single gateway. It's a single IP. It's very easy. No need to maintain on failovers. It's very clear what's going on there. So this is another level of improvement. Member addition. It's very smooth along the years. Development that a new member is validated, checking his version number and the build number, and if the build is if the member is going to be part of the security group and it doesn't have the same version as the other members, it just clones it or full configuration, install the new version, and then is ready to act as part of the members. Obviously, members with different versions are not recommended, not supported, shouldn't happen. Members in the same security group must have the same version. So this is very easy. It's like one step, one member, one hardware operation, plug in or put the SGM in the empty slot, go to in the software, configure the newly added SGM, and wait for a few minutes, 5 to 10 minutes sometimes, depends on the traffic. And many operations are being happening in the background. Once everything is okay, the new SGM will also be ready to handle traffic. Traffic processing, and this is a dramatic notion or characteristic. It's that multiple active members for each VS. So even if you have a VS6 or VSLS, for example, you have a VSX with 2 VSs. So one VS number 1, let's say that it's active on chassis 1, and VS number 2 is primary and active on chassis 2. So all the members on chassis 1 will process traffic for VS1. All the members on chassis 2 will process traffic for VS2. So here we have a growth from HA that we have in cluster Excel, which only one per member handles traffic, and also for VSLS, only one member handles traffic for a given VSLS. Here we have a growth of up to 12 by a multiplier of 12 per VS. We're getting into Maestro in a bit. So this is a 64, this is a 64K, 44K, and this is how Maestro looks like. So you can just imagine where we are getting at, because it can grow much higher levels. Some concepts related very briefly about scalable platforms concept. So a security group. Checkpoint supports a single security group or multiple security groups for a given system, for a given deployment. Each of them can be a security gateway or VS6. The same you use for smart dashboard, nothing special in terms of configuration. A smart dashboard, the same way you configure and maintain a standard single gateway devices. Again, if it's a security gateway or VS6, it's the same. All configurations, interface, IP addresses, routes are synchronized to all members transparently. No need to do anything manually. It's to all members of security group. So if you have multiple security groups, each security group synchronizes to its own member only. One or more hardware nodes can be part of security group. One or more security groups, we said that. We said this as well. A single IP address per security group for management communication. So we have many SGMs in a chassis or in a dual chassis environment, but only one of them, it's like, it's usually, by default, it's the lowest ID of an active SGM is communicating with the management device. And after the communication, after the information was received by this SMO, the single management object device or member, one of its roles is to populate or distribute this information to all other members in the security group, and then all of them are applying the new configuration concurrently. An alternative design could be that each member is communicating with the management, but it was much more significant more communication on the network layer, and also it will be a mess. So this is very simple to track what's going on. SMO, we said. Traffic load balancing mechanism across security group members. So there are, if you go back a bit, so these cards in the middle, in the 64K and in the 44K are in the top, they are processing cards. Okay, so once a packet was received on one of the ports, it's the hash function is being applied on the packet, and according to some decision function, the packet is being distributed to one of the SGMs, and this is how traffic is being distributed. The pretty standard load balancing. Usually, the default distribution function is related to the IP or the source IP, destination IP, source port, destination port. It's a static distribution, which has its the simplicity gains much more stability as opposed to a potential dynamic distribution algorithm, which is much more maybe dependent on the CPU level, which is much more complex to implement and make the system stable. So, so this static distribution function has its limitation on some edge cases, which happen sometimes, but it's generally speaking very robust, for sure, with comparison to dynamic load balancing. Correction, traffic correction, as there are many SGMs acting in practice is active-active for a given virtual system. So on quite a few cases, there can be cases of which the traffic is not symmetric by default because it cannot be in the way I introduced before. So there are multiple correction layer implementation that make sure the traffic is being handled by the same member at any time, and also taking care for synchronization. Take for example NAT and VPN. We change in these protocols or applications. The IP is being modified So it will be the networking card doesn't have the ability to make the stickiness decision. So the correction layer is taking this responsibility. Now we're getting into Maestro. Maestro key concepts. So Maestro is the highlight. So ability to grow firewall continuously and dynamically. You don't have a chassis box. You don't have anything that bounds you. You can take one of the boxes that you have in your data center, and you just need to edit with a very simple commands. Ability to mix and match hardware. So you can use for a given security group 1, you can use hardware of type A, and for the other security group, a bunch of hardware nodes of type B, and this work seamlessly. In the chassis solution, but it was not supported. So even if you have multiple security groups, you need to use the same hardware. So we said this one as well, and ability to scale beyond the capacity of the chassis platform. Checkpoint supports officially up to 52 nodes per Maestro device to act as active-active, which this is an insane number. On some performance KPI, it's very easy to go. It's very linear. And some others, it's less. For example, if we talk about throughput, throughput is really linear because it doesn't matter if the throughput is 1 gig or 50 gig. This information is not being synchronized. On cases where there is synchronization, it's a bit more challenging because the CPU on each member have also an overhead, so it's more complex to define the exact number. But again, for KPI like throughput, it's a really linear growth. So you really, when you buy and deploy the system, you don't need to be too defensive in your calculations, because you know that whenever you will need to go, you will just go without any other network changes. Only adding the device, adding it to the relevant to the Maestro, to the ports, putting it in the power, and mostly that's it. Future support of all model range. So this is not 100% true. It's like the vast majority of the appliances. Chassis and SMB is not relevant to that. Chassis and Maestro doesn't make sense to work together. But for all others, it's totally supported, meaning that, and something which is very important here is that you can either buy new hardware or reuse existing hardware that you had for Cluster XL. So take into consideration that you have like maybe, I don't know, 10, 20 clusters of Cluster XL. Each one of them had 2, 3, 4 members. You can just migrate them. Again, you have, let's say we have a Cluster XL of 4 members in HA. We can migrate them into a single security group connected to Maestro. Then you receive active actually, because a security group is acting in active. So this is really, really important. This is a very good innovation, and reuse for your existing hardware. First version will be based on R80.20. So these are the main highlights. Orchestration layer. So this is a rack, and you've got on the top of the rack, you've got one orchestrator or 2 orchestrators. The orchestrators are both, they're expanding each other's, but they can be configured also to be in sync. So if one is going down, to the other one is taking charge, and making sure that the things are continue to work properly. And then on the bottom, we've got the computing resources. So you can have up to 52 nodes for a couple of orchestrators. So this is it. In terms of, if we go a bit, I think that this is the lowest we will get in terms of low level. So there are 4 types of interfaces. There are the management ports to manage the actual orchestrators. And there are the traffic, the uplinks, which are connected, the blue ones, which are connected to the external switches. There are the downlinks, which are connected, each member, each node in the security group is connected, need to have a cable from the node to each orchestrator. But so this is like this is the parallel of the backplane connectivity on the chassis. Okay, so if I add a new member, I need to plug to the power. I need to add one cable to orchestrator 1, another cable to orchestrator 2, and that's it. And then in terms of hardware maintenance, operations, and then I need to add it to the security group to configure it as a new member, and that's it. And starting then, it's same concept that I described for the scalable platforms before. So it applies both for the chassis and both for the Maestro. So many things are automated. So we said uplinks, we said downlinks, and also the sync, the sync interfaces to sync between the two orchestrators. Okay, I will not go through this. Okay, so in this slide, we can see visualization of different security groups, of multiple security groups. Again, to emphasize, they can be of a different version, different appliance. Obviously, a version that is supported, that Maestro supports, but it was started at R80.20 SP, and but moving forward from this version, it can be different security groups can use different versions, obviously different configurations, totally independent. VSX, security gateway, the software blades used, just has nothing to do with each other. In terms of security, they don't communicate at all with each other. So we have this table that is making the comparison. I will not go through it. I will just edit it here. So if one wants to have a look at it in a summarized way later on the web, you can use it, but it really doesn't say anything new than what I said before. That's it. Indeni. So the way Indeni supports Maestro. So Indeni monitor and alert the orchestrator itself, the one or two. Indeni monitors and alert each security group. So what we do is we do general health checks, networking status, identify performance problems before they affect the system. This is the aim, not only to notify when we have problems, just before we get them, so we can act in a proactive manner. Misconfiguration identification, application status, DNS, NDP, things like that. Internal mechanisms for the vendor, for Maestro, core access, secure access, software blades, more and more and more. And each security gateway is added as a separate device. Security gateway in VXX supported, expandable to support new metrics, collection, and alert. So at this point in time, we mainly support the same level as we supported the chassis in R80.20 SP, but on our roadmap is to add new functionalities that are related specifically for the orchestrator for Maestro. And the Indeni platform is very flexible and expandable. So everything which we find you, the administrators, the IT guys, professional services, checkpoint support, whoever finds new thing that requires automation, it's very, very easy to edit. Auto triage is supported, and we have hundreds of different alerts that one can get on its device. So this is the Indeni UI. So we have, as you can see, we have added before, we're connected to Maestro setup. We have a Maestro orchestrator and one security gateway, one VS6, each one of them configured with a given IP. If, for example, I go to the security gateway, I can see that I have multiple issues, recent issues that we have. You can see different information here. Then when I click on one of the problems, for example, iCPU usage per core, so I can see different information. I can click on the CPU, can see what's going on and analyze it. We have additional information on each CPU. We have a history in the notes section describing exactly the timeline of events, so we can have a track what's going on. If we have many times when we have CPU problems, so it's very important to have the history so we can try to figure out what was going on in the system. When we're going to the same, I was displaying now for the security group, but the same thing is for the orchestrator. So this is the Knowledge Explorer. If on the left tab, the actual issues, the Knowledge Explorer is like it's not an active issue. It's like all the things that we support potentially. So I put a filter. I applied a filter for vendor checkpoint and OS Gaia, and then I can see many alerts that are supported for Checkpoint Gaia. The vast majority of them supported for SP as well, so you can see them. We have automation. This is the ATE that I described before, the auto triage. Just to align the attendees, maybe some of you are not aware of or well familiar with our terminology and what we do. But in terms of, we have the AD, we call it ADE and ATE. ADE is like auto detect element and ATE is auto triage element. And the ADE is actually is the part in the component in our system that collects information continuously from each device, and whenever there is a problem, we create a trigger and alert. The ATE comes on top of as an extension on top of a created alert. So if, for example, an alert for anti-pissing failure occurred, so we mark it here with this symbol, and then we go into the actual ATE and review what happened there. I click now on the overview. And then what we actually do in the ATE, we do a deep analysis of trying to look for the root cause. In the ATE itself, when we trigger, until the ATE was introduced, we gave remediation steps, which was static. And then one can go to the internet, look in some website, do some stuff as per general recommendations. In the ATE, what we do is we actually we are applying multiple device tasks. We call it device tasks. We are applying multiple commands, and after each command is returned to the Indeni server, we are doing additional checks. If that, do this, others do other things. So you see, for example, in this case, for the NTP, we check the configuration, and then we check if it's on, if save config I applied, and we get different conclusions. And this is our bottom line that we are looking for a conclusion. So everything I've just described is relevant for Maestro transparently. We have today released already 27 ATEs totally for panel for Checkpoint. And if you have something on your data center that is not appearing in our current offering, you're welcome to notify us for our product and our support, and we will put it on our roadmap so it can later on, if it will reoccur after we provide it, it will make your life easier with automating the identification of the root cause. So this is about that. You can add also report or graph. So for example, on the left bar, we have the graphs. Before that, we were on the issues. We started at the devices. Now I'm going to the graph and the report. And I'm trying to add a new graph, for example, for security gateway. Check, let's say, OS, again, CPU, and you can see lots of information here. So this is our system in the lab. I think that's pretty much sums the way about Maestro and Indeni with Maestro. Alexa?
Thank you, Shai. We had a few questions come in during today's presentation. As a reminder, you can still submit these through the Q&A pane below. Our first question is, how does Indeni server collect the data from the Maestro security group for analysis?
So as I mentioned earlier, so the Indeni server collects the information on a periodic basis for each collecting script we have a monitoring interval, and Indeni sends a command to the security group IP. As we said before, each security group is configured with a designated, which is a configured IP on Indeni server. And once the information is being received, the output is received, we parse it, we create different metrics, so we populate our database, and then we look for problems with values which are abnormal, and whenever a value is abnormal, we trigger an alert.
Great, thank you. The next question is, how does the workflow work with Maestro setup?
So the workflow is working the same way it is working with other devices. Nothing special about the fact that it's a scalable platform. We communicate with the IP, which is configured, so we get to the SMO, and we receive the information from the SMO. So in cases of which we need to have information from all members, so we collect it from all members. And other cases when the information is already aggregated on the SMO, so we collect it from the SMO. And once the information is retrieved, we do the analysis on the receiving side in the AT and decide how to move forward accordingly.
Great, and the last question is, how can I access a trial to Indeni? I can answer this. So we will be following up with our free trial where you can download our Indeni licenses. But you could also access that on our website at www.indeni.com. As a next step, we encourage you to leverage our follow-up resources to gain more insight into how Indeni delivers out-of-the-box verification of best practices for Checkpoint. As a reminder, we'll share these resources with you after the webinar along with the live recording. So this concludes our webinar. Thank you again to everyone who joined us, as well as to Shai for presenting today. Enjoy the rest of your day, everyone.